Okay, everyone, this is our Lab 4. Lab 4 is about integrals. And let's first calculate the first question, these two definite integrals. Okay, first one, using the power rule for integral, we get the antiderivative is x to the power 3 half over 3 half minus x squared over 2. So we evaluate at these two boundaries, we get the answer. So yeah. So here you need to evaluate and find a fraction or a decimal for the answer. Okay, that's this one. The second one, the integral of 2 to the power t, the antiderivative is 2 to the power t over log 2. Oh, okay. So again, we evaluate at the boundaries and evaluate and get one answer, right? That's the second one. Okay. Let's look at the second question. The second question is about there is a factory, so it will give this like pollutions, some waters, polluted waters, and the pollution rate is given in this table here. So this pollution rate means the derivative, right? So question 1 asks us to estimate the total amount of the total quantity of pollution that entered the lake during the whole month, right? So there are two cases, the smallest case and the largest case, right? So in between the day day 0 to day 6, there are two options for this pollution rate, either be 7 or 8. From day 6 to day 12, there are also two options, like the extreme case, either be 8 or 10. The others are kind of similar, either 10 or 13, either 13 or 18. Or 18 or 35, right? Okay, let's take this possibility and calculate using this data here. So this tells us the total quantity of pollution should be integral from 0 to 6, 7t plus from 6 to 12, 8t plus from 12 to 18, 30t plus 18. Oh, this is, excuse me. The third one should be from 12 to 18. Here is 10t plus 18 to 24, 13t plus 24 to 30, 18t. Right? That's the lowest case. Right? Let's just calculate. So this is 7 t squared over 2, integral from evaluate from 0 to 6. Similarly, this is 8 t squared over 2, evaluate from 6 to 12, plus similar all the way to the last one, 18 t squared over 2, integral from 24 to 30. And you add all these numbers together to get the lowest case. And the upper estimate, right, the largest case should be integral from 0 to 6. Here we use the largest possibility, the 8 here, right, 8t. Here is 10t. Here's 13t. Wait. Did I miss something? Oh, right. Here. From 12 to 18, 30t to 13t. From 18 to 24, 18t. From 24 to 30, here we use 35t. Right? So you integral and get a number. That's the upper estimate. So the reasonable assumption here we make is that the pollution rate is increasing, is monotonically increasing. Right? That's the assumption we make here. And question 3 gives us this graph here. This graph is the rate of change for the stock price of this CAU stock over 5 days. So question 1 asks, at what time during the 5 days period was the stock at its lowest value? Right, it's increasing here because here is positive, and decreasing and decreasing. And here is its lowest value, right, at day 3. And the question asks us to compare these different values of P. So let's take P0 to be itself. P0 equals P0. And let's take this brick here. Its volume is unit 1, right? So P1 equals, let's do some estimate. So P1 equals P0 plus this area, right? So this area, you take this little triangle and put it here. This is just this unit rectangle. So it's P1 is P0 plus 1. P2 equals, so P2 is P1, which is P0 plus 1, minus this amount, right? This area here. But this area is a little bit bigger than 1, because when you connect these 2 points, you will see some little area here, right? Let's call this little shaded area epsilon. Minus 1 minus epsilon. So this should be P0 minus epsilon, where epsilon is a very small number. Okay. And let's look at P3. P3 is, again, you need to minus this area, right? This area is 1 plus epsilon. So P3 is P0 minus 1 minus 2 epsilon. Right? Okay. What about P4? P4 is P3 plus this 1/2. Right? So plus 1/2 is P0 minus 1/2 minus 2 epsilon. And P5 is, you add this one, this is 1, this is another one, so add 2. This amount add 2 is P0 plus 3/2 minus 2 epsilon. So let's compare them, which one is the largest one. So it's kind of clear that this P5 is the largest one, right? In the increasing order, okay, in the increasing order, which one is the smallest one? The smallest one should be P3 here, right? P3 is the smallest one, so P3 first. Then which one is small? Is second one? Second one should be P4 here. P4 is P0 minus 1/2 minus 2 epsilon. And then P2, right? And then P0. And then P1. And then P5. That's in increasing order. So that's this question, okay? And question 4 is a population of 2 species of trees, and their growth rate is given in this graph here in the blue curve and the green curve. So question 1 asks which species will have the larger population after 4 years and after 9 years. So as you can see, the blue one is the area under this blue curve is larger than the area under this green curve, right? All the way. Like at time 4, it's clearly this area under this blue curve is bigger. At time 9, this after year 8, the green curve becomes the growth rate becomes larger, but it's only overtakes this amount of population. But here we have this larger amount of population for this blue one, right? So for both 9 and 4 years, the blue one will have larger population, right? But as you can see, the blue one, when time goes by, the blue one becomes, the increasing rate becomes, the growth rate becomes smaller and smaller, but the green one, it keeps increasing like an exponential function. So as you can imagine, after 20 years, the green one will have bigger population because it's keep growing, right? Keep growing. Okay, that's question 4. And question 5 is about a tank of water is leaking at a rate. The rate is drawn here in the graph. And question 1 asks us to write a definite integral of the value corresponding to amount of water lost from time 0 to 9 minutes. So yeah, so the integral is basically 0 to 9 integral of RT dt. That's it. And so this integral is basically ask us to calculate this area under this curve, right? So how to estimate this area? We basically, a good strategy is to estimate by assume all this smooth curve, make it broke into line segments. So let's draw the line segment estimate here. Sorry. Right. Yeah. Use this right line segment to do this estimate. So this part, yeah. So each of this rectangle have area. How many area? So its length. This horizontal length is 2. Vertical length is 5. So the area is 10. Right? Each rectangle have area equals 10. So let's, how many entire rectangles? 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 cross times 10 are these entire rectangles. Here, this one plus this one, this is a entire rectangle, so plus 10. And this one is half, plus 5. This one here is an entire rectangle, so plus 10. This one here is half, so plus 5. So that's the estimate. Let's calculate it here. So this is 16, 17, 18, 19. So 19 cross 10, 190, right? That's the amount of water lost during the 9 minutes. Okay, that's all for Lab 5.